Hello there. Today we are going to start the series of videos on machine learning also. So today my first video of machine learning, let me make it a big screen. Let me check it out with the pointer. And then today we are going to see something about representation, future vector, what is future space and all those things in machine learning. And we also see about dimensionalities in today's videos. So first, what is a future? Future, or let's take an example. We'll give what do you mean by future means. Future is nothing but, if you take an example, we say that it's an attribute which specifies the things. Like if you take a house, a house is something very good, but how many rooms are there, how many bathrooms are there, and what are the size of a room, and what are the size where it is located, and everything. Factors might include that number of rooms, number of area, how close to the stores, what is the owner, and what are the facilities which are available, like stores. An example, like if I take an input of sperm male, then include number of words, how many are the words used, preparation of certain words, and everything. Means it just like a thing which can able to explain you the properties of all those things which are very important part of it. Now if I take a human being and I can say what are the attributes of a human being, I can say it has got two hands, two legs, and a face. Correct. These are some attributes of it. Now if I take a student, now if I take a student, how can I identify a future of a student? That is student ID, student name, and which year, and voila, it's a management or government quota. Correct. These are the properties of that student. The same way is nothing but, these are nothing but your attributes, these which are nothing but your future of your machine learning. So let me go out to it. Like we have got a task, sperm male, what are the inputs of this male? I've got a, how you are going to predict it with the based of the input. Now how do you know that's a student? Based on its input I can going to predict it is there. Then a number of inputs on this figure I can able to, based on this input I can able to predict the images. Then how do you predict the price? Based on the input I can, based on the input I can able to predict it. Then how do you know the chessboard is playing? Based on my input I can able to predict it, this one. So what is the task? Is a sperm mail or something like that. Based on this one I can able to predict it. What are the inputs of the car? Car has got two or four tires. It's an automatic car. It is we have got sunroof and everything. Then what are, based on this input I'm going to predict it. The number of inputs, sorry, based on this one I'm going to predict it. Now how do you play? Based on the chessboard I can able to predict it. So the more number of input you give, based on that task I'm going to put my output there, or the more number of inputs which I give, based on that one I'm going to tell you. Thus this can able to tell us. Correct. Now let's take an example. We have got a use diagram which is there, use of algorithms which are there. We have got common features of that, common representation. Then we create a future of this one. Then we can able to use the algorithms, we use the futures, then we can able to predict the values. Correct. Then what is the male? If I've got male, so many words are this, and I can represent it, I can represent that as sperm male. I've got images, there are a number of images. Based on this one, if I find this one based on the pixel, I can represent it. I have a car, based on this features I can able to, this is a car, this is an automatic car, this based on the crossboard I can able to predict it. Then common representation. What are the common representation? How you are doing it? Then you are using an algorithm. Based on your input and then algorithm we are going to predict this one. This is nothing but the futures which you are going to present it. Now there are two slides. There are, let's take example. I told you about this one, number of words, number of the number of spell appears, number of errors. Now the same way here, number of words is 173, number of the words represented is 17, number of spell errors is nothing, number of spelling error is 13, number of blue pixels is this much, and the number of bright levels are 71, Then RPG values is that is red, green, blue values are nothing but this is the values. Number of dog in images, there is no dog images. Now if I say it, this one also, the number of rooms which are number of available are rooms. Area of square is 300 rupees, 300 area of square feet is 1000, and a distance from the nearest market is 1. These are the features of it, and these are some properties of data point which are represented on this one. Different type of features, I can say future can assume the values, that is numerical, binary, and gender. All those things comes in your futures. Rule of futures which we are going to see, that is a rule based, search based, and data drive approach. I'm going to tell you all those things. In a rule based decision, rules are being applied on the input properties. Search based, we are going to apply some rules, and then we are going to go for a mathematical approach. And then there are something which is called data driven yes or no methods which are represented on this one. Now some of the properties of data points are, these are numeric yes, and then there are binaries yes or no, these are binaries one which are represented. Then we are categorize, that is male, female also. Then we have got sequence of statements. Some other properties of a data points, or we call it as features. Correct. These are the points of the features. Now let's move on to other one. Then I just told you rule based, checking the condition. Based on this one, I'm going to check if input what is the weather today. Based on my rules, I'm going to get the output. Based on my rules, I'm going to get the output. Then I just data driven combination. What are there? If this I just told you this one, data driven based on the combination. Yes, number of words are this, number of this one, though it's not a sperm. And then what is the other one which I have sent you up? This is search based, searching based on the input, searching. Like you have got what you call best first search, or we call it as other one, searching methods, which I forgot it. Later on when I remember it, I can able to tell you in my class. But there are some rules which are this in a space diagram, we can able to represent that one. Correct. Now we have got something called data points. What are the features? Based on this one, I can able to predict it. If the number of rooms are more, if the area is more, then distance of the market is near. Based on that one, I can able to predict. There are, what are the features which can able to do? This is a rule based one. Which one is this one? Rule based one. Then again this one is, the other one is data driven method. I have written it. Based on this one, we can able to predict the value. Then how do you predict the futures? How do you? That's manually, right? Future engineering, we are going to input the values automatically. We have taken from somewhere down the line, and then we are going to future in extraction, that we are going to see later part. But there are point, how do you enter the values? There are we are going to give it enter manually, or you are going to take it from other one, and this part feature in my next videos which are coming down to the line. Then there are some useful unuseless futures. What are there? Who is the current owner of that I don't need. Correct. In my features there are some rules, like if I have got a student, and then I don't want his student's parents occupation. What are the parents? Mother occupation. Its father is occupying, that's fine. And parents, and I don't want their location, where it is the location, house is located, how far it is from the college, and everything. These are all unnecessary things for any machine learning algorithm. These are useless features which are we can able to say it. Then future vector. What do you mean by future vectors? I have seen you. What do you mean by future? Come down to here. What do you mean by future? These are the futures. Correct. Attributes. Now how do you future vectors? Future vectors are something which are important, that is represented in the form of a matrix. Correct. That is presented in this form, collection of numerical features. In every value, if any value which is not in a numerical value, then we have to convert them into numerical value. That is, we are going to get yes or no, y 0 or 1. As computer states, computers knows only a numerical value. We have number of words 173, 61, no, that is 0. Then we are converted into this values. Correct. Number of pixel, this, and there is no 0. We converted this into this one. Number of frame, we have converted into this one. Standard presented formulas, then we put into the input, and we get the desired output. That is, whatever the values of attributes you have got, we have to represent in a form of matrix. The diagram is being shown, or the slides is very important for you. The next part is label. What do you mean by label? The name given to that one, right? This is a cat, this is a dog, which is used in supervised learning. Label is the most predictive tag, like human being, which is label is also known as a tag, which is used for identifying a piece of data that tells you some information about that element. Label also requires final output, what you want to add, predication. Right, if I want to predict a dog, it has got 4 legs, it have got a long ear, it have got the other things, then I can able to label this is a dog label. If I have got it have got 4 ears, and this it has got 2, this is the face it represented this one, then it can able to tell you. That is called a label. Label versus unlabeled data. Labeled data that has got predefined tags which are used, that numbers, for example image, apple, banana. And at the same time unlabeled data that has no tag, nothing has been given to it. Labeled tag is used in supervised learning, unlabeled tag is used in unsupervised learning. Label is nothing but tag, name given to it, first thing. Second thing is that it is used in, or output tag, it is used in supervised learning, and unlabeled tag is used in unsupervised learning. We can able to tell you in coming videos. Today's I'm just going to tell you about I'm going to tell you about future and how do you represent future vectors. These are the things, and in that part label also comes into it. Then there comes a future space. Then I have got attributes, we call it as future, and we represent it in the form of matrix. That is called what we call future vector. And how do you represent in a graph? We call this one as future space. Do remember the attribute, we call it as a future. Then how do you represent in a mathematical format? We call it as a future vectors. And if you represent in the graph, that is called future space. Now I have got a data point. I have got a email 1, email 2, not spam, and that I've got a data point of 2 things, what is called house 1 and house 2. So number of words, just remember it, 31, and number of words are this. I have represented in the form of space that in a graph representation, correct? This is called future space. Do remember it. So I have got 2 graph which I have represented in this one, sperm 1 and sperm 2, which is not a sperm, correct? So I have represented in the form of a graph. But the problem comes up. We have got 2 dimensionalities, but each one is of same color. So how do you identify that one is a sperm whale, other one is a not sperm whale, based on the properties? These are the properties which are represented in the graph, and they are of same colors. Then how do you identify that is one is sperm whale, another one? If you check this graph, all the labels are of same colors, so we don't have any information about that. So we will change. Next slide. Let's see it. We will change it. Sperm we make represented with the help of red, and I have just changed the color, not sperm. So we represent in a different format. So whatever the matrix we have got it, what are the attributes we have got it, we represented in the form of matrix. Then we represent it in a state space diagram, like a graph which is represented. That is called number of words and number of words, which are different words. Now we have got 3-dimension arrays, correct? We have got 3 properties, 1, 2, future 1, future 2, and label. 3-dimension, that is 2 feature, 1 label diagram. Then how do you identify that one? So that how we go for different path, that is for classification and regression. N dimensional features are available, and minus n plus 1 dimension features are available for that one. The next one is here. Then the properties of features. Now if I have drawn a graph, that is one feature is representing this, one feature is also representing this, one feature is also representing, one feature is also representing this, one feature is also representing this one, means these are all close properties, close feature. They have got similar properties. We don't have to represent of them each of them, or we can say that they have closely related to each other. They are closely related to each other. Let me take out a different color pointer, pen. No, it's not giving me color. Let me check it out. Anything color comes up. Screen pointer in color. Yes, I'll go with this one. There are of same colors which are available here. There are of same properties. So choosing a feature speller, we call it as a we have got similar properties. Correct? They've got similar properties. This is the future properties of that one. If 2 points are very near, we call that as they've got a similar futures. So represented is there something like that. Again, I repeat it. My attributes are nothing but my futures. How that futures are represented mathematically is nothing but future representation. Future represented in matrix form. Then in space, if I represent, we call it as a future vector. Correct. Now we come up to other part called dimensionality. Then what do you mean by dimensionality? We have got n number of futures. Correct. N number of futures, but we don't need that n number of features. Like if I said you have, I have got a student, which I have got student ID, student name, student address, and then we have got student phone number, student date of birth, DOB, and other things. These are all properties. Now, why there are dimensionality reduction of my features? So that I can get a desired output, so that I can get a desired output, so that I can get a desired output. Selection of this is divided into two parts, that is feature selection and feature extraction. So these are divided into two parts. What is called feature selection and feature extraction. Feature selection is that whatever the selection, if I've got 1, 2, 3, 4, 5, 6 attributes, I can able to select 5 attributes which are very important to me and just give me the output. The same way I have got 10, select which 7 which give me the best output of that one. That is called feature selection. You have got filter, wrapper and embedded methods in that one. And we have got feature extraction. We are going to make it a large data set, is that taking what is important. That is what this one is, this one, and here it's create a new feature, means principal. It give me, there are about 10 sets which are not there, which are very important to me. It give me a new data set that it able to identify which are more useful from that one. That is what future action. There is a different videos which I am going to make based on this too, but today what we have seen it, let me rewind for you. What are the things we have seen it? We have seen something about feature, we have seen about feature vectors, then we have seen about properties of feature vectors, then we have got rule based feature, data driven, search based, then we have also seen useless, what are the unused useless features, then we have also seen what do you mean by ob labeled, then we have seen future space, then we have also seen something about dimensionalities. Dimensionalities is something like that where we are going to reduce the features to get a desired output. There are, how do you reduce that features? There are two types. One is feature selection, other one is feature extraction. In feature selection we have got wrapper, filter, embedded. There, if you have got 10 attributes, I can able to select 7 and I'll give you the best output. And how do I select it? Based on these properties. And if I've got features, there is a different properties. I'm going to get a new data set based on applying this one. I'll get a new data set which can able to define the properties. Correct? These are the things which we are going to see today. Thank you very much.